lesson 10.6. So we are finishing factoring. In 10.5, we did it when a was just 1, so we didn't have to worry about that number at all. Now in 10.6, we're looking at factoring when you have a number other than 1 for a. So like 2 or 3 or something like that, and a constant, okay? So the whole goal of factoring is to be able to solve quadratic equations, okay? So when you look at a quadratic in standard form, it would be ax squared plus bx plus c, okay? And we've learned that factored form means to write it as a product of linear binomials. So we know that that's going to be something like mx plus p times nx plus q, okay? And when we FOIL, we end up having m times n times x right here. So we get m n times x squared, because you get the m and the n, and then x times x would be x squared. And then you would get plus, so that's the first, then the outer would be m times p, and that's going to have an x on it. And n, or m times q, sorry, m times q, and n times p. And then that gets your x, and then your constant here is, so that's the first and the outer and the inner, and then your last two terms are m, or p times q. Okay, so what this is telling us is that you are looking for factors of a, right? So if we line this up, this tells us that a is equal to m times n. So we need factors of a and factors of c. That's our constant here when we line it up. That when you take the combination of them, so you're taking a factor of a and a factor of c and multiplying them. So a factor of a times a factor of c plus the other factor of a times the other factor of c, that's going to equal the middle term. Okay, so to factor, we're going to look at the factors of a, factors of c, and try to combine them to get b. So for example, if you have the quadratic 2x squared plus 11x plus 5, okay, I know that this factors 2x plus 5 times 2x plus 1. Okay, we'll look at how I was able to get that, but I'm telling you that that works, okay? So then when we FOIL it out, we see that we get here 1 times 2, that's your 2x squared. Those are your factors of a. And then your constant here is the last two terms. So 5 times 1, which is 5, okay? And then for b, it's your, and when you look at FOIL, this is first and last. It's your outer two terms plus your inner two terms to give you b. So the outer two would be x times 1, right? So that would be 1 plus 5 times 2. And that's how you get your 11x. when you FOIL. Okay? So let's see how we figure that out on our own. Okay, so we are looking to factor 3x squared plus 5x plus 2. Okay, so a is your leading coefficient, so it's the value with your x squared. B is your value with x, and C is your constant. Okay, so we're going to start with A. So in this one, A is 3, and your constant, which is 2. So just your number. Okay, then we're going to list all factors of A. If A is positive, don't worry about the negative factors. Okay, so factors of 3 are just 1 and 3. We're going to do the same thing for your constant, okay? Even though the constant is positive, you still want your negative factors. So the factors of 2 are 1 and 2, and negative 1 and negative 2. Okay, you don't worry about the negatives for A if A is positive. Then we know that B is the value with x. So we have to look for a combination of factors of A and factors of C that are going to give us 5. Okay, so I'm going to start with the first set. So when you work through, try to keep it organized. So I'm going to try 1 and 3 with 1 and 2. And you're multiplying. So 1 times 1 is 1, 2 times 3 is 6. If I were to add 1 plus 6, do I get 5? I don't, so that does not work. Okay, but we're going to try switching them and say, well, what if I use 1 and 3, still use 1 and 2, but I'm going to do 2 here and 1 here. Okay, and then multiply. 1 times 2 is 2, 3 times 1 is 3, 2 plus 3 is 5. This is the factor pair we want. Okay, now what's left to do is to set up what goes where. Okay, when I'm factoring, I'm looking for binomials. So I always know it's 1x in each. Okay, then the factors of A are 1 and 3. They go with x. So I'm going to make it a 1x and a 3x. You won't really have to write the 1, but just so you can see where my factors went, okay? So 1x and 3x, because those are my factors of A. Factors of A go with x. Then you're trying to figure out where your factors of B go, okay? So these are the factors of B. In order to get 5, we needed 2 to be multiplied by 1. So if I have a 1x here, the 2 goes in the opposite parentheses because when you FOIL, you're multiplying across parentheses. The 1 factor of C that's 1 got multiplied by 3, so the 1 has to go in the opposite parenthesis from the 3x. So I get x plus 1 times 3x plus 2. You can always check your factoring by re-multiplying it out to make sure you get what you started with. So we factored now 3x squared plus 5x plus 2. Okay, let's look at one. You have a couple more examples in your notes, but let's look at one that has more factors of A, okay? Because then the more factor choices you have, the longer the problem gets, unfortunately. So if we start with 8x squared minus 14x minus 15, okay? So it's on the second page of your notes. Still want to know what A, B, and C are. Okay, you always start with your factors of A and your factors of C. So a is your coefficient on x squared, so a is at 8, and c is always your constant, so c is negative 15. You have to take the sign with it. Then I'm going to list factors of these two. So factors of 8 are 1 and 8, 2 and 4. And that's all of my factors for a. Then do the same for 15, or negative 15. So 1, negative 15, negative 1, positive 15, 3 and negative 5, negative 3, positive 5, and that's it for your factors for negative 15, okay? Then you have to see what b is. So b is negative 14, because it's the coefficient on x. So we're going to try to see which combinations between a pair from A and a pair from C that will give us negative 14. Okay, so I'm going to start with 1 and 8 because I just want my list to be organized. You don't want to jump all around. Okay, so I'm going to try 1 and 8, and then I'm going to go down my list here. 1 and negative 15. Okay, well 1 times 1 is 1, but 8 times negative 15 is a big number. Okay, so I think it's 120. Doesn't really matter exactly what 1 plus negative 120 is. It's just not 14. Okay? Then you're going to try this way. So we're going to do 1 times negative 15 and 1 times 8. So negative 15 plus 8 is negative 7. So that doesn't work. Okay? So 1 and 8 does not work with 1 and negative 15. The next pair would be 1 and 8 with negative 1 and positive 15. All that's going to happen here is the signs are going to change. So it would be like a negative 1 and a positive 120. So still not going to work. So I'm going to try 1 and 8 with 3 and negative 5. Okay, well 1 times 3 is 3, and 8 times negative 5 is negative 40. So that doesn't work. Okay, then going the other way, 1 times negative 5 plus 3 times 8. So negative 5 plus 24 doesn't work either. Okay, even if I were to switch the signs would swap here, and it's still not going to work. So 1 and 8 does not give us what we want. Okay, so now we're going to try 2 and 4 with all of these. So we'll do 2 and 4 with 1 and negative 15. Well, 2 times 1 is 2. 4 times negative 15 is negative 60. So 2 minus 60 doesn't work. Then if we go this way, 2 times negative 15 is negative 30 plus 4 doesn't work. Okay, then we'll try, again, if I just make this a negative 1 and a positive 15, I'll have a negative 2 plus 60, or 30 minus 4. So it's not going to work. So now we're going to do 2 and 4 with 3 and negative 5. Okay, so 2 times 3 is 6. And 4 times negative 5 is negative 20. Well, 6 plus negative 20 is negative 14. That's what we want. So this is the combination we're going to use. Okay? So we have to figure out how to set up our parentheses. So we know we have 2. We know we have an x in each one. Then the factors of a go with x. So I'm going to have a 2x and a 4x. And then you have to figure out where your factors of c go, okay? So when I look here, the combination that worked was doing 2 times 3. So if I have 2x here, the positive 3 goes in the opposite set of parentheses, okay? And the negative 5 got multiplied by 4, so they go in opposite parentheses. So I get 2x minus 5 times 4x plus 3. Okay? All right. So one other thing you want to do when you're factoring is we want to try to make it as simple as possible. So if you can factor something out from every single term, it will make it a little easier for you. So when we're looking at this last problem on the second page, okay, the 6x squared plus 9x minus 27. I can factor out a 3 from all of those terms first, and then I start with a equals 2 and c equals negative 9. But it has to come out of all 3 terms. You can't just do it out of 1 or 2, okay? All right, so you can use factoring now to help you solve a quadratic equation. Okay, so if I want to solve 8x squared plus 10x minus 11 equals 12x plus 10. Okay, so just like we've done in the past, you have to, it's a quadratic, you have an x squared and an x term, so we're going to put everything on one side and get it equal to 0, and then we can factor. So I'm going to subtract 12x, and I'm going to subtract 10 from both sides. So I'm going to end up with 8x squared minus 2x minus 21 equals 0. Then I'm going to factor that, okay? So a is 8. Factors of 8 are 1 and 8, 2 and 4. And the constant is negative 21. So factors of negative 21 are 1, negative 21. We could do negative 1, positive 21. 3 and negative 7. Negative 3 and positive 7. Those are your factors of negative 21. And then you want b to equal negative 2. Okay? So check your factor pairs. When you do 8 times 21, that's big. So the products have to be fairly close together, right? So we're looking to try and shorten our list. So if I multiply 8 and 21 are larger numbers. So 8 times 21 is a really big number. So that's probably not going to work. And then 8 and 21 are far enough apart. So let's maybe start with 2 and 4 and 3 and 7. Okay, so 2 times 3 is 6. 4 times negative 7 is negative 28. Not really close enough. So if I do the other way, 3 times 4 is 12. And 2 times negative 7 is negative 14. And 12 minus 14 is negative 2. So that's our factor pair, okay? So we're still solving. So it's equal to 0 now. We know we have an x on each parenthesis. And then the factors of 8 are 2 and 4, so they go with our x's. To get this, we did 2 times negative 7. So 2 is in this parenthesis, so negative 7 goes here. And then we did 3 times 4. So the 4 is here, so the 3 goes in this set of parentheses. So now it's factored, but then you have to solve for x, okay? So we use a zero product property. We're going to be able to set each of these equal to 0, 2x plus 3, and 4x minus 7, and then solve for x. So subtract 3 from both sides and divide by 2. So x equals negative 3 over 2. Or if we add 7 and divide by 4, we get 7/4. So we get our 2 solutions for x. Okay? All right. This is something else I'm going to add to your notes for you. This is a new way. So what I just showed you was how I've always taught and how I was taught how to factor. This is a second way. Okay, it might make more sense. I'll attach them as well, and I'll kind of go over what this is, what that way is showing you. It might be a little easier for you guys. So 2 ways. All right. So what this way says, and I just have an example on how to do it, okay? If we're looking at something like 14y squared minus 15y plus 4, okay? The last term, so the constant is positive. So the final, like when you're setting up your parentheses, it's going to be either both are going to be positive, so it's going to be plus and plus, or they're both going to be negative, okay? So you're going to get it's going to be plus and plus, or minus minus, okay, in your parentheses. Then what they tell you to do is they tell you to take your coefficients for A and C. So here is A and C. We have 14 and 4, and multiply them. 14 times 4 is 56. Okay? Then, so we're going to do A times C. Then you are going to factor. We're going to take 56 and factor it. So 56, factors of 56 are how did it, okay, I don't like that. So 56, 1, 56, 2, and 28. Okay. 3 a factor. 3 is not a factor. 4 is a factor, so 4 times 14. 5 is not a factor. 6 is not a factor. 7 is a factor, so 7 and 8. That should be all the factors of 56. Okay, so we're looking for which factors of 56 multiply to 56, but add to negative 15, because that's B. So they want to be multiples of A times C, but they have to add to B. So now we're going to look at these. B is negative 15. So these are, it's positive 56, so it can be both positive or both negative here. Okay, so 1 and 56 don't work. 2 plus 28 doesn't work. Negative 2 plus negative 28 doesn't work. 4 plus 14, right, this is going to be 56. So positive or negative 57. This, if we add them together, we're going to get positive or negative 30, positive or negative 18. Then 7 plus 8 is 15, but we want negative 15. So we're going to use negative 7 and negative 8. Okay? So once you have that, then you're going to go back to your original expression that you're trying to factor, okay? And I'm going to replace the b term with these, okay? So we're going to leave 14. Then we're going to leave the constant, and we're going to replace b with these values. So it's going to be minus 7y minus 8y. Okay? Then you're going to find the greatest common factor of the first two terms. Put these together. And the second two terms. So these two, I'm going to factor out a 7y. Then if I divide both by 7y, I get 2y minus 1. And here I'm going to factor out a negative 4. So minus 4 times 2y minus 1. Okay? Then they both have a 2y, so I can take the 2y and factor that out. So then I get 2y minus 1, and then what's left is 7y minus 4. Okay, I'll attach those for you. That is new to me, but it is something that could possibly work for you. If you have questions on either way, let me know.